Well, New Mexico is known as the Land of Enchantment, home of the Department of Earth and Planetary Sciences at the University of New Mexico. Our mission here is to both develop new geoscience knowledge and also to train the next generation of geoscientists for the future. One of the themes that we're particularly proud of is our work on water, energy, and the environment. This kind of research has geoscience at its very core, and we have an opportunity here to contribute not just to the general knowledge, but also to understanding of problems that society faces.
One of the greatest things about teaching geology in the state of New Mexico is that rocks are laid bare across the state.
Right here we're sitting in the Sandia foothills, and this uplift is due to the development of the Rio Grande Rift. And the Rio Grande Rift is one of the most well-studied and definitive examples of a continental rift system anywhere in the world.
The work we're doing here in the Rio Grande Rift to understand the fault networks is really critical to understand these deep fluids which are moving into our groundwater system, moving into the aquifer system, and even sometimes erupting into our river systems, surface water.
Well, water is an incredibly important natural resource, and water-stressed areas are expected to expand as the climate warms. So we really need to understand the processes that are governing that so we can make better policy decisions.
My research program here at University of New Mexico is looking at the geology of aquifer systems and reservoirs, petroleum reservoir systems. And so we use outcrop analogs, go out in the field, use terrestrial LiDAR, and map and model those aquifer sediments. This research helps us understand how the contaminants move through the groundwater systems, how, in terms of energy, how petroleum will be able to produce that petroleum better, and also how to produce uranium in a safe way from in situ mining.
I'm able to use tools that are used by the oil and gas industry when they're trying to discover hydrocarbons. These techniques that I use are also used by the environmental sector to look at groundwater flow and the shapes of underwater reservoirs. They're also used by folks who are looking at geohazards such as tsunamis and earthquakes.
We also install monitors, which allows us to literally take the heartbeat of the Earth from her circulatory system, that is the hydrologic network, and understand changes through time. This is a very exciting aspect of environmental monitoring that is providing baselines that will allow us to compare what things are like today to changing futures that we might experience because of climate change, as one example.
My research focuses on the global hydrologic cycle, and we see that the water vapor transport globally is changing as a result of global warming. We're trying to understand why that's happening and how that will impact water resources globally, especially in arid areas.
My research focuses on CO2, carbon dioxide emissions from volcanoes. And we are trying to understand how much deep mantle carbon is emitted through volcanoes worldwide and how those emissions vary with time and volcanic activity. If you want to understand the entire global carbon cycle and how humans affect that carbon cycle, we need to study volcanoes.
One of the questions that I'm trying to answer through my research is understanding the activity that's going on, the convective activity in Earth beneath the tectonic plates, and how that influences geologic activity that occurs far from plate boundaries in places like New Mexico, where we have young faults and volcanoes that aren't very near a plate boundary. So something must be going on beneath the interior of the plate.
We're the flagship University of New Mexico, and we have a minority-majority population, much like the United States itself will reflect in a few years. We have especially vibrant populations of Hispanic and Native American students that are actively participating in studies that will help them marshal the resources and develop things in a sustainable way in the future, especially in our theme area, water, energy, and the environment. We have the opportunity here to really train the face of the future in terms of the geoscience community.